Okay, I welcome all the students in the world of computer graphics. Today's session, we are going to learn the point super sampling method and pixel phasing. In previous session, we have learned what is meant by the aliasing and the aliasing effect. Okay, and we have also learned what is meant by the anti-aliasing and which are the different anti-aliasing techniques. Okay, so we have learned what is the super sampling or pre-filtering, post-filtering. Okay, so now we are going to learn today's session these two things or these 2 points or techniques in detail, okay, with the help of example. Okay, super sampling and pixel phasing. Okay, so these are the points that related to polygon filling algorithm we are going to cover in the next session. In today's session, we are going to cover the super sampling in detail and pixel phasing in detail. Okay, so I just move to the next slide. So we have already learned what is the definition of super sampling. Okay, what is mean by the super sampling? Okay, so super sampling is one of the method used for anti-aliasing to remove the aliasing effect. Okay, we are using super sampling, and the general definition that we have considered for super sampling is it is a technique of the super sampling is a technique of sampling object characteristics at higher resolution. Okay, so we are trying to sample at a higher resolution and display the result at a lower resolution is called as the method of super sampling. So we are learning the super sampling. Okay. Now we are going to see how this super sampling method I can apply for a straight lines. Okay, how I can apply the super sampling method to the straight line. Okay, because we have seen that due to the effect of aliasing, the straight line may be a jagged lines, it may be a staircase effect, or they are not drawn, okay, the straight. Okay, so now we are going to consider this is how we can apply this to the straight line. Okay, now we can divide the pixel, to apply the sampling to the straight line. Okay, what we are going to do is we can divide the picture into number of subpixels. Okay, so we are going to divide the pixel. Okay, so one pixel is divided at number of subpixel to increase the resolution. Okay, now if I want to increase the resolution, what I'm going to do is I just divide my pixel into number of subpixel and count the number of subpixels that are along the line path. Okay, that are along the path of the line. Okay, so here in short we are going to increase the resolution of pixel. Okay, resolution of pixel is increased by dividing it into the subpixel. Okay, now after doing this, okay, after finding this, the intensity level, okay, the intensity level of each pixel is then set to the value which is proportional to this subpixel count. Okay, so proportionally we are going to change the intensity level, okay, of the each pixel to avoid the aliasing effect. Okay, so just consider an example. Okay, so we will see this diagram now in the next ppts as shown in the diagram. Okay, each square pixel means, suppose I'm having, see what I'm showing over here, suppose I'm having a single pixel. Generally the pixel is represented as a square. Okay, so as a grid. Okay, now each square pixel is divided. So what I'm going to do, this is my 1 pixel size. Okay, so my pixel size is very high, means I'm working at low resolution. Okay, so what I'm going to do is I will divide this pixel into 9 equal sized subpixel. I'm divide this into the 9 pixel. So I just have, suppose I consider this is my one side. Okay, this is first, second and third, and here you can find it at similarly. So what this shows or what this indicates that this is my 1 pixel, this is my complete pixel. Okay, 1 pixel. Okay, this is my complete 1 pixel. I have divided now this pixel into 9 equal size subpixel. So dividing it into 9 equal size subpixel, and we are going to show that the shaded regions, So the subpixel that are selected by the Breslum's line drawing algorithm. Okay, so out of this 9 subpixel, we are going to find out which are the subpixel which are highlighted, okay, which are selected by the Breslum's line drawing algorithm or any line drawing algorithm. Okay, now after doing this, okay, what we are going to do is provide the 3 intensity setting levels. It's going to provide us, or we are going to provide the intensity levels, since the maximum number of pixels that can selected within a any pixel is 3. Okay, so maximum out of this, okay, maximum 3 pixel can be selected, okay, that can be covered. So we are going to set the 3 intensity levels, okay, above the 0. Okay, now to understand this concept, okay, I think you have understood that my 1 pixel is now divided into 9 pixels. So I have divided my 1 pixel into the 9 subpixel. Okay, so obviously my resolution will be increased, so I'm calculating this at a higher resolution. Okay, and while displaying I will again go back to the lower resolution. Okay, so let us understand this in the example in detail. So I'm just moving to the next slide. Yes, you can find this. Okay, so I'm having this diagram, so you can find out this diagram. The same thing is here. So 1 pixel, okay, suppose I consider, just now I have shown this is my 1 pixel, okay, is now divided into 3 subpixel. Okay, you can find out it is divided into the 9 subpixel. Okay, so we are having this 1 2 3 4 5 6 7 8 9 sub. Okay, and this is what my line is shown. Okay, so I'm having the line which is aimed at the position, or I'm having one of the end point of the line is 10 and 20. Okay, so at actual this 10 and 20 is nothing but this is my complete pixel. Okay, so 10 and 20 is nothing but it is my complete pixel. But what I have what we have done, we have divided this into the 9 subpixel. Okay, so we have divided into 9 subpixel. Okay, so now just consider this example. Now if you can consider the pixel at position 10 comma 20 is set to the maximum intensity level 3. They will ask why. Why it is set to the maximum intensity level 3? Okay. Now why it is set to level 3? Because inside this 9 subpixel, I am finding there are the 3 pixel which are on the path of the line. Pixel number 1, pixel number 2, pixel number 3. Okay, you can find that the 3 pixel, there are the 3 pixel which are going to, or 3 subpixel rather I say, these 3 subpixel are going to cover the path of the line. So the pixel at 1020 is set to the maximum intensity level 3. Getting me? Okay, so what is written here? Super sampling subpixel. Just look at the diagram, explanation of the diagram or description of diagram. Super sampling subpixel positions along a straight line segment whose left end point is at the screen coordinate 10, 20. So this is 10, 20 pixel. Okay. Now you will ask what we are going to do about this next pixel. Okay, so this is the description that we have written. Okay, so just look at this, that you will understand the super sampling method in detail. The pixel at 11 comma 21 and the pixel at 12 comma 21. Okay, so this is 11 and 21 means which pixel now? So I am talking about this particular pixel. Understand? Okay, this is the pixel which is shown at the 11 and 21. Okay, 11 and 21. This is 11 and this is 21. So this is the pixel, and which is the another pixel? 12 comma 21. Okay, so this is 12 and 21. Okay, so now I am talking about this particular pixel. Okay, so now what is this 2 pixel? Now this 2 pixel 11 comma 21 and 12 comma 21 are set to the next highest intensity level 2. Okay, so it is first is 11, 10 comma 20 is set at level 3, and these two are set at intensity level 2. Why it is 2? Because you can find inside this pixel there are the 2 pixel which are going to cover the path of the line. This is my actual pixel. Okay, so this is my original pixel. Out of that the subpixels are there, so I'm finding that this is my subpixel number 1, this is my subpixel number 2. Two subpixels are there. If I talk about this particular subpixel, again I am finding there are the 2 subpixels are there. So 2 subpixels are going to cover the path of the line, so it has set at the intensity level 2. Okay, Now you can ask me what is going to happen for this particular pixel, okay, this one, okay, and what is going to happen for this particular pixel. Okay, so that is what my next point. The pixels at 1120 and 12,22. Okay, so this is my pixel at 1120. This is 11 and this is 20. 1120. It's easy. 11 and 20 means which pixel? This pixel. Okay, 1120 pixel, and another is 12,22. This is 12 and this is 22 means which one? This pixel. Okay, so these two pixels are set at what intensity level? They are set at the lower intensity level 1. Okay, they are set at intensity level 1. Why? Because out of these 9 subpixels, only one pixel is on the path of the line. Here's the same case. Out of these 9 pixel, only one pixel. See, this is only one pixel which is on the path of the line. So it is set at lower intensity level. Okay, so according to, after dividing it into the subpixel, how many pixels subpixels are going to cover or which are available on the path of my line, depending upon this, what we are going to do is we are going to set the intensity level. So obviously the intensity level of this pixel will be high, this will be less than this is also less than this, okay, this will be equal, and so on. Okay, so this is what we are going to do. Now what is the advantage of this? Okay, what is the advantage of this particular method? Therefore, or thus, the line intensity is spread out. Okay, line intensity is spread out over a greater number of pixels. Okay, line intensity is spread out over a greater number of pixels, and the staircase effect. Okay, and the staircase effect is smoothed by displaying the somewhat blurred line path in the appropriate value. Okay, so just we are considering here, so in appropriate value that we are going to do it. Okay, so that is what the advantage that we have seen. Okay, let us move to this point, let us move to this discussion. Okay, I'm just continuing with my discussion. Okay, now while we are doing the super sampling at a straight line, okay, so we are just considering the description is, okay, I think before going to this diagram we just see that if we take, now this is another way of achieving the super sampling is, if we take the finite width of the line into account, okay, if we consider the finite width of the line into account, we can perform super sampling by setting each pixel intensity proportional to the number of subpixels inside the polygon, okay, representing the line area. So I think now that is the reason, I think this is my line. Okay, I just show somewhere here, this is my actual line. Okay, so my actual line is this, so I'm just going to cover, but now I am using this as the super sampling subpixel position in relation to the interior of the line finite width. So like I'm now, I consider my line is this. Okay, as per the direction of the line, I consider this is my line. Okay, so I'm considering here the pixels are there which are on the path of the line proportional to this particular number representing the line area, and this will be more easy or more helpful us to remove the aliasing effect. Okay, so this is going to remove the aliasing effect appropriately. Okay, now in that case, if I consider my pixel, now you may consider that, okay, this is the pixel is going to cover, this is there, so appropriately, okay, we are going to set the intensity. My actual line is this. Okay, this is my actual line, but now what I have done in super sampling, what we are going to do in super sampling is we are going to calculate the pixel or represent the pixel at higher resolution. So instead of considering it as a one pixel, I have divided it to 9 subpixel. Okay, and now I am going to consider this, okay, which is the better method. Okay, so now what is the advantage? What is will happen due to this is we represent this line. Okay, we represent this line with finite width by positioning the polygon boundaries. By positioning the polygon boundaries means automatically the polygon boundaries are there, or these line boundaries are there which are having some jagged effect, which are having staircase effect, that will be removed. Okay, parallel to the line path as shown in this particular diagram. Okay, so this is what our purpose or of understanding the super sampling. Obviously in this particular grid, see what I'm saying, in this particular grid, suppose my line is like this. Okay, suppose this is my line. Okay, now what I am going to do as per our method, what we are going to do, I have considered my line is not only having or it is calculated as lower resolution, but it is calculated higher resolution. So I'm just going to cover or consider all the subpixel over here. Okay, my actual line is this, but I'm going to cover all this subpixel whenever I'm going to draw the line to remove the aliasing effect. Okay, I hope all of you are very much clear with okay what is the way that we are doing the super sampling method. Okay, so and appropriately we are going to set the intensity of this pixel. Okay, so I'm just moving to the next slide. Okay, so I think before moving to the next slide, I think we just mentioned the advantage here. Okay, so what was the advantage of this is the total line intensity is distributed over more pixel. Okay, so total line intensity is now distributed because I have divided into number of subpixel. So the total line intensity is distributed over more pixel, and there will not be any effect. Okay, or aliasing effect is removed. Okay, so let us move to the next slide to understand the method. See, here one of the method okay that we are using in the super sampling is called as pixel weighted mask. Okay, we are going to use the method as pixel weighted mask. Okay, now what is this pixel weighted mask method is? Okay, see, super sampling algorithms, okay, super sampling algorithms are often implemented by giving more weights, okay, by giving the more weights to subpixel, by giving more weights to subpixel, okay, near the center of pixel area. Okay, giving more weight to subpixel near the center of pixel area. Since means suppose okay, I've just considered here. I think we are going to see in the diagram also. Okay, so if I consider, I think before we are going to see the diagram, I just want to mention it here. Suppose this is my pixel. Okay, everyone knows this pixel is centered or address at the center. Okay, so this is the center of the pixel. So now what we have to do is we have to give more weightage. Okay, more weightage is given to the center of pixel area. Means the area of the pixel which is at the center is having the more weightage. Okay, and other areas or the areas at this particular side are not having more weightage. They are having less weightage. Okay, less weightage is given or less intensity values are given. Okay, because the center of the pixel area means this is the center of the pixel area, and since these subpixels are more important in determining the overall intensity of the pixel. Okay, so let us see this in detail with the example. Now I want everyone to concentrate on this particular example. See here what we have shown is the relative weights for a grid 3 by 3 subpixel. Okay, just now whatever I have drawn, trying to draw the diagram and want to show it here, is shown here in detail. Okay, my actual pixel, see I repeat again, my actual pixel size is this. Okay, so whatever I am showing at the outer line, this is my actual pixel size. My actual pixel is this. Okay, but now I have divided this into the 9 subpixel. Okay, we have divided it into the 9 subpixel, and what is the center of my pixel, or which is the center subpixel, rather I say this is my center subpixel which is having the higher intensity level. Okay, weightage, the weightage of this is 4. Okay, you can find what is the weightage of this. The weightage of this is 4. Okay, that is what I have written. For a 3 by 3 subpixel, a weighting scheme is shown in the diagram. Just now it is shown in the diagram. Now we can find here the center subpixel here is weighted 4 times. Okay, so center subpixel is weighted 4 times that of the corner subpixel. If I compare this 4 and this is 1, so it will be weighted 4 times. Corner, these are the corner subpixel. Okay, and that of the corner subpixel and twice that of the remaining subpixel. Okay, you can find what is the intensity or we can say weightage of the other subpixel. If I consider the weightage of this, if I consider the weightage of this, if I consider the weightage of this, and if I consider weightage of this, see these are the 4 connected subpixel. One subpixel at the okay, we can say at the left, right, up, top and down, or up and down. So all these 4 pixel which are connected to the center subpixel, okay, are now having the intensity value are now having the value which is 2. Okay, or the weightage is 2, which is the twice. Okay, so this is the highest subpixel weightage. Then the next subpixel weightage is given to this this and this. Okay, that is what we have written. Okay, and we have given, you can find out, we have given the very less weightage is given, a very low weightage is given to the corner pixel, corner subpixel. This is one, this is one, this is one. So these four corners, this one, this one is the one corner. See, all these four corners are having the very less weightage, that is only one, as compared to this pixel. Getting me? And that is what the method which is known as pixel weighted mask. Okay, now why this is referred as mask? That is what I have written here. An array of values specifying the relative importance of subpixel. Okay, value specifying the relative importance of subpixel is referred as the mask of subpixel weights. Okay, referred as mask of subpixel weight. Okay, and that is what we are considering pixel weighted mask method, which is used here. Okay, I hope all of you have cleared with the discussion that we are having. Okay, let us move to the point. Okay, next slide. Now, whatever the different method that we have already used, okay, but one of the method which is more accurate or more beneficial in the anti-aliasing, that is called as filtering techniques. Okay, so we are calling and we are using this method which is known as filtering technique. Okay, so that is what I have written here. A more accurate method for anti-aliasing is to use the filtering technique. Okay, use the filtering technique. Okay, now what this particular method filtering technique does, the method is similar to applying a weighted pixel mask. Just now we have seen the weighted pixel mask method, so it is more similar to applying the weighted pixel mask, but what is the difference is but a continuous weighting surface. Okay, continuous weighting surface or a filter function, continuous filter function covering the pixel is there as shown below. Okay, there are the different methods are also there, so we just look at the concentrate on the diagram. See, these are the different methods, so comes under the filtering technique. Okay, which are this method? So the method is box filter, the method I'm using maybe the cone filter, and I'm using the Gaussian filter. Okay, Gaussian filter. So these are the different filtering methods, okay, which are used. Okay, you can find the description over here. Common filter functions used to anti-alias line paths. The volume of each filter is normalized to 0. Okay, so the volume of each filtering method is normalized to 0. Okay, and the height gives the relative weight at any subpixel position. Okay, and we are using this method. Okay, so here what we are going to cover is, what we are going to consider here is in the box filter. Okay, obviously just we have know that again here the same example is there. My actual pixel is this. Okay, which is divided into the 9 subpixels. Okay, so these are the dividing lines to divide it into the 9 pixel. And if I apply the box filter, obviously this is my center pixel which is having the highest weightage, and now I am going to cover the box method, whatever part is covered by this box. Okay, whatever the box filtering there, then that appropriately the intensity levels are set. Okay, so the same is shown here as a cone filter, cone filtering method. We have used this modified of the cone filter, we are calling it as a Gaussian filter. Okay, so all these methods are also used on, which are also more accurate methods of anti-aliasing, okay, which are used. Okay, so these are the methods that we have just discussed, okay, which are comes under the filtering techniques. Okay, and that are having the n number of different filters are there. Okay, just as an example, we have seen box filter, a cone filter, a Gaussian filters, and so on. Okay, so these are the methods used for the smoothing purpose. Okay, to smooth your image. Okay, so we are using, generally in the smoothing the image, what we are going to do is we are going to work on the intensity level. Okay, so here also, as I have mentioned here, weighted pixel mask method is used. Here also we are using the weighted pixel mask method. Okay, so what we can find out, we can find this is the center pixel, obviously it is having the very higher intensity. After that we are going to change the intensity, so this, up to this part it is going to have the more intensity. But for these are the different parts, we have to set the intensity level which is very less. Okay, and then we will get the smoothing effect, and these are the method that we are using and we are calling, which comes under the filtering technique. Okay, so continue our discussion. I'm just moving to the next slide now. Okay, now we are going to see what is mean by the pixel phasing. Okay, so this is one of our important part that of discussion. What is the pixel phasing method? Okay, now I just see the description that we are having on the raster scan system or on the raster system that can address subpixel position. Okay, now by considering the subpixel position within a screen grid, okay, what the pixel phasing does, the pixel phasing can be used to anti-alias object. Okay, pixel phasing can be used to anti-alias object. Okay, now the stair step along a line path, the stair steps along the line path or the object boundary are smoothed out. Okay, so in pixel phasing also we go for smoothing of the stair step effect or staircase effect. Okay, on the line path or maybe the object boundary. At the boundary we are going to have this a staircase effect. Okay, and we are trying to smoothing out that particular effect by moving the electron beam. Okay, so we are just changing or moving the electron beam to more nearly approximate position specified by the object geometry. Okay, so that is the method that we are using and we are calling it as the pixel phasing. Okay, now if you look at this particular diagram, okay, so you can find that this is the diagram number A. I think I've just shown this as a diagram as an example. In diagram number A, I'm finding there are the jagged lines. Okay, so there are the jagged lines. Number of jagged lines are there. You can find that this particular diagram here I am having so many lines which are jagged. You can find there is a staircase effect here. Yes, this line is not smoothened. There is a staircase effect. So many problems are there. I am finding this particular diagram. Okay, and this all the lines on this diagram are jagged lines. Okay, plotted on the some we are considering as the Merlin 9200 system are smooth. Okay, and after smoothing, after applying the pixel phasing method, okay, after applying the pixel phasing method, okay, we have reached to the diagram number B. Okay, so we are you can find that this staircase effect is there. If I'm finding this staircase effect is there, okay, so we are having jagged lines. Now you can find all these are removed here. Okay, so this will be more appropriate or accurate result I'm getting with the help of the pixel phasing. Okay, there are so many jagged lines, so many staircase effect. All these are removed with the help of the pixel phasing method. Okay, and that is what this particular diagram. This is the diagram without applying any super sampling or pixel phasing, and this is the diagram. Okay, this is not correct diagram. It is having so many problems. Okay, and all these will be smooth. Okay, and I'm finding that all these are removed with the help of the pixel phasing. Okay, so I hope so all of you cleared. Okay, how what are the change? This is the original, and this is after applying the pixel phasing. I will convert it into it. I'm finding all these lines are smooth. If I consider this particular line, I think so many jagged effect lines are there, so many staircase effect, and somewhere maximum all these are removed here. Okay, okay, so this is what the explanation of the diagram. Now, uh, how this is achieved? How this is achieved? Suppose I am having the jagged line over here at the boundary. Okay, at the boundary side, I am having the jagged line here, boundary pixel. What we are going to do? The electron beam is shifted by, so electron beam itself is shifted by 1 by 4, 1 by 2, or maybe 3 by 4 of a pixel diameter to plot the points closer to the true path of the line or the object edge. Okay, so I think I'm finding whenever there is an object edge or the line edge I'm finding here, which is not correct. So I'm just going to electron beam it shifted. Okay, by maybe 0.5, 1 by 4, maybe zero point 0.5, and so on. Okay, and at the pixel diameter to plot the points which are closer to the actual path of the line. Okay, or which are closer to the actual object edge. Okay, and I will get the very good result, smoothing result with the help of the pixel phasing. Okay, now we continue our discussion of the pixel phasing here. Okay, but now why we are having such effect? Okay, why we are having this jagged line appearance, why we are having, so that is the reason. Okay, we are moving to some of the last point of the our today's discussion. Here, why I am having such effect is because we are having unequal length lines. Unequal length lines are displayed with the same number of pixels in each line. Okay, unequal length lines are displayed with the same number of pixels in the each line. Okay, now if I'm finding this is the line, I think you can find what is the gap. There is a gap or the difference between every pixel. Okay, in the diagonal, this is one, there is a gap, but you can find this particular line. Okay, all the pixels are very close to each other, so obviously for this line the intensity or brightness of this line will be very high. Okay, whereas for this particular line you can find there is a gap between the pixels. Okay, they are not equal length, this is having the different length, this is having number of pixels are same. Look at this, number of pixels are 1 2 3 4 5. 5 pixels are there. Here also I am having the 5 pixel, but the length is, they are not equal length. Okay, there is unequal length. Okay, so the brightness of this particular line may be less as compared to the brightness of this line will be higher. Okay, so that's why we are having such effect, and for removing this we are using the pixel phasing method. Okay, and the all anti-aliasing method. Okay, so just look at one more example of this. So to complete our anti-aliasing method discussion, anti-aliasing concept can also be applied to the boundaries of area. Okay, so we are going to apply it at the boundaries of the areas to remove their jagged appearance. I want to remove the jagged lines. I want to remove the jagged appearance. Okay. So where I am going to apply the method, I am going to apply the method at the boundary area. I am going to apply it at a boundary area. Okay. So the method, what this method does, the method adjusts each pixel intensity at a boundary position. So we are going to adjust. See, the word is very important. Adjust intensity, pixel intensity level. Adjust pixel intensity at the boundary position according to how much percentage of the pixel area that is inside the boundary. Okay, how much pixel area is inside the boundary and how much pixel area is outside the boundary. Okay, by observing, by considering this, how much percentage of the area is inside the boundary and how much percentage area is outside the boundary, what we are going to adjust, we are going to adjust the pixel intensity, and that will help us to me to remove this jagged appearance. Getting me? Okay, just continue our discussion and we will see with the help of the diagram also. So you can find in this diagram. Okay, suppose I have having the polygon, I'm having the triangle. Okay, and this is my line. Okay, this is my actual line. Okay, so this is my actual path of the line. Okay, this and this is my polygon edge, you can consider. Okay, now what is going to happen now here, if I'm consider, obviously these pixels are inside, this is also inside, this is also inside, this is also inside, this is also inside. So this 3 plus 2, all these 5 pixels are inside. Okay, all these 5 pixels are inside the polygon, and obviously their intensity is very high. You can find the color intensity, brightness, though it is a blue color, it is having the very higher intensity or the brightness is very high. Okay, now what we have to do, if I activate this pixel, boundary pixel, see which are my boundary pixel, this is my boundary pixel 1, then this is 2, then this is 3. Getting me? These 3 boundary pixels are there. If I activate these 3 boundary pixels with the same intensity or color, obviously I will have the jagged line. I think I may get the effect something like this. Okay, which again a jagged line. Okay, now to remove this effect, what we are going to do, we are going to adjust each pixel intensity. For example, suppose I consider this pixel. Okay, what is the value of this pixel? X, the pixel is at x comma y. The pixel is x comma y. Now this pixel is going to have 50% outside, 50% inside. This pixel is 50% outside, this pixel is 50% outside. So I have to set the intensity of this particular pixel, which is 50% of the actual intensity. Actual intensity is this. So 50% of this is activated. So this pixel is activated with the 50% of intensity. Okay, I think I have written this. Just look at this. Yes, we have written the same thing. Pixel at position xy. So position x and y, this pixel has half of its area inside the polygon boundary and half is outside. Okay, therefore the intensity at that position should be adjusted to one half its assigned value. So actual intensity, you can find this actual intensity pixel. All these pixels are at actual intensity. Out of that, 50% is applied to this because 50% part is outside the boundary, 50% is inside. Okay, I hope so all of you understood it. Okay, now what is going to happen for this pixel now? X plus 1 comma y plus 1 means this pixel. What is going to happen for this pixel now? Yes, anyone can assume this. At pixel x plus 1 comma y plus 1, at pixel x plus 1 y plus 1 along the boundary, okay, we can find only some part, very less part is inside and maximum part is outside. So I say 25% part is inside, 25% part is outside. Okay, for this particular pixel y plus 1 and x plus 1 in this pixel. Now I am talking about this particular pixel. Okay, now along the boundary the intensity should be adjusted to 1 by 4 because 25% is inside, okay, and 25% is outside, so I'm having very less intensity level. Okay, color is same but intensity will be changed, or about one third or one fourth of the assigned value, and you can find this is there in this two pixel. Okay, for this pixel as well as this pixel, intensity value is one third or one fourth. Okay, whereas for this pixel x comma y, we are having the 50% of the intensity level. For all other pixel, it is as per the assigned intensity. And due to this, by applying this, okay, by applying this method, it is possible for us to remove the jagged line appearance. We are going to remove the appearance of jagged line. Okay, so if I activate with the same intensity, obviously there will be the staircase effect. Okay, and if I'm just going to use the adjust, I'm going to adjust the intensity level, pixel intensity level at the boundary position according to the percentage of pixel area that is inside the boundary or inside the polygon. Okay, so all these pixels are inside the polygon, they will have the appropriate intensity. This pixel is 50% inside, 50% outside. I will activate this pixel with the only 50% intensity, whereas this pixel and these two pixels, they are having very less part inside. Okay, you can find only 25% is there, only 25 or 30% part is inside, remaining part is outside the boundary of the polygon. So intensity of this pixel will be reduced. Okay, and it is reduced one third or one fourth than the assigned value of this pixel. Okay, and due to this, I think it is possible for us to remove the jagged line appearance. Okay, and this is what the method of the anti-aliasing that we are calling, which comes under the pixel phasing. Okay, adjusting the intensity level. Okay, or we can say that we are giving the weightage. Okay, is given. Okay, adjusting the pixel intensity along the area boundary, that will help us to remove the staircase effect or aliasing effect. Okay, so I hope so all of you have understood these two methods of super sampling in detail and the method of pixel phasing in detail. Okay, so these are the anti-aliasing method that we are using, and there is always the importance which is given to the anti-aliasing techniques or anti-aliasing method. Then and then only the end user will see the very correct image, or it will not find the uh, problem or aliasing effect on the displayed image or displayed line. Okay, so this is what our the topic of discussion, okay, for today's session. Okay, so I hope so all of you understood what is meant by the super sampling in detail with the help of different example and the diagram, and the pixel phasing also in detail. Okay, we stop here. Okay, in the next session or next lecture, we are going to discuss about polygon filling algorithm. Okay, thank you dear student, thank you all.